To understand the history of debiasing efforts, we will begin with the history of studying bias in psychology. With Alport's 1954 book titled The Nature of Prejudice, there was now a touchstone for the study of prejudice and bias in the field of psychology. More recently, however, the idea of implicit social cognition stems from research done on controlled versus automatic processing. Controlled processing was determined to be voluntary and of limited capacity. Meanwhile, automatic processing happens without our attention and is hard to suppress. Next, Fazio's sequential priming task was tested. This is similar to the modern-day implicit association task, where reaction times were measured between words that fit stereotypes versus words that don't. Next, the implicit attitudes were defined as introspectively unidentified traces of past experience that mediate favorable or unfavorable thought or action towards social objects. In the early 2000s, intervention trainings became more popular. In the counter-stereotype exposure, participants are exposed to images depicting members of the stigmatized group in ways that are in opposition to the stereotype. In evaluative conditioning, the person who is the subject of a stereotype is paired with another object that is not aligned with the stereotype, so that the stereotype loses its strength. In approach training, participants negate stereotypes by pressing a button labeled No when they see stereotype-consistent images. In intergroup contact, interaction between different social groups is facilitated. Today, debiasing training is commonly used in many workplace trainings. In lots of Silicon Valley companies like Google or Facebook, employees are shown videos like this one as part of their training.
It'll help you develop as a leader and to do your job even better.
It made me realize how often I have a very strong belief that is simply incorrect. When I look at one of these evaluation situations, the first question is how can I eliminate the sources of potential bias and leave just the data so we can actually make better decisions?
If you're not conscious of the biases that you have, you're just not contributing at the level that you could, and you're not innovating at the level you could, and so your products won't be as good.
We will now go through a brief background of the cognitive processes necessary to understand debiasing. Our brains rely on two general levels of processing to perform activities, intuitive and analytical. System 1, or intuitive processing, describes our unconscious, fast, automatic mechanisms that solve problems quickly and are used for everyday decisions. System 2, or analytical processing, describes effortful processes that are reflective and resource-intensive, used for more complex decisions and focused activities. System 1 relies on using heuristics and less effortful decision-making. As a result, this kind of processing is more prone to error or bias. Many implicit stereotypes, for example, rely on System 1 mechanisms to make quick assessments of people we are seeing for the first time. Debiasing is an attempt to forget implicit biases and form accurate associations for a given stimulus. Most debiasing techniques focus on shifting cognitive processing from System 1 to System 2. In other words, System 2 is essentially used as an executive override for System 1. This process is not realistically possible with simple one-shot interventions. Most debiasing methods take time, with consistent intervals of effortful processing to overcome inherent mistakes. We will now take you through a series of studies that explore different debiasing strategies.
Evans and his research team designed a famous task to test the strength of a certain type of perceptual bias. In this task, subjects are told, if there is not a red square on the left, then there is a yellow circle on the right. In completing this task, participants are asked to break the rule. One way to falsify the rule is to put a blue square on the left and a green diamond on the right. However, most subjects respond with a red square on the left and a yellow circle on the right. Here, a form of perceptual matching bias overrides the logically correct response. Evans attributes this to the not heuristic. Note that a heuristic is a mental shortcut. Here, the word not in the rule acts as a heuristic by directing the participant's attention to the proposition that it denies. So we have an example here of a bias that is affecting the participant's reasoning. Is it possible to overcome a bias like this one? In Howard's 2000 experiment, participants completed the task that was described in the previous 2 slides. This task is done during a pretest and a post-test. Between the pretest and post-test, participants take part in a 20-minute long training. During this training, participants are first warned about the trap of perceptual matching bias. They are then given a different task called the Watson's classical card selection task. This task is similar to the previous one in that participants must overcome a perceptual bias to choose the logically correct answer. Following training, during the post-test with the previously used task, participants were able to choose the logically correct response almost all of the time. It seems like this type of training actually helps with inhibitory control of a bias.
Another approach to debiasing, in a study conducted by Renner and colleagues, had participants routinely estimate their confidence about exam scores to reverse biasing effects of overconfidence. In the study, participants completed a quiz weekly over a 10-week period. There were 3 groups. 2 of these were given immediate feedback after completion of a quiz. In these cases, graded quizzes were returned after each class. One of those classes was asked to provide a confidence estimation before each quiz. The third class was given delayed feedback, where quizzes were returned at the following class meeting. Results showed a significant increase in performance for the immediate feedback group, which generated a confidence estimation. The immediate feedback group without confidence estimation had no significant change in scores, and the delayed feedback group actually showed a significant reduction in scores. This demonstrates that introspective assessments of an individual's knowledge in an effort to honestly gauge preparedness can improve performance in the classroom. In another study, Hines and colleagues designed an experiment where novices, intermediates, and experts at a particular task were asked to predict the time it would take for a novice to perform the given task. In this case, it was learning how to use a cell phone for the first time. Participants first made an unaided prediction, which was just based on a brief description of the task and the novice's background regarding the task. Participants then underwent some sort of debiasing before the next prediction. Half of participants underwent a recall-based debiasing method, which involved recalling past experiences related to their expertise. The other half underwent a list-based debiasing method, which involved the participant reading information about typical problems novices deal with relating to the task. The study found that novices and intermediates were significantly more accurate with their predictions both before and after debiasing, while experts greatly underestimated performances in each condition. This raises some interesting questions about general debiasing strategies because in this case, the effectiveness of the debiasing method depended on the participant's level of experience.
Now we will return to the first debiasing example that we discussed, in which participants overcame perceptual matching bias by undergoing training. When the participants were carrying out the pre- and post-test tasks, they also went through a PET scan to monitor brain activity. Researchers compared brain activity during the pre-test and post-test to determine the regions that seemed to be playing the biggest role. During the pre-test, when participants still exhibited a bias, many occipital regions were activated. Specifically, there was activation of the bilateral middle occipital gyrus, right cuneus, bilateral supramarginalis gyrus, Wernicke's area, and left angular gyrus. Imaging following training showed activation in left prefrontal networks. Specific areas include the middle frontal gyrus, Broca's area, anterior insula, and pre-supplementary motor area. The data here suggests that when participants use a different strategy for decision-making, there is also a shift in the brain regions involved. Overall, we see a shift from posterior regions to more anterior regions. The shift following training likely reflects cognitive inhibition of perceptual matching. Activation of Broca's area likely reflects inner speech, which is known to have a self-regulatory function. Pre-supplementary motor area activation likely shows a state of preparedness for selecting the appropriate motor response. Long-term potentiation and long-term depression both are thought to be key in learning and memory. During these processes, synapses are either strengthened or weakened, respectively. If a certain synapse is used less, i.e., something is unlearned, then the synapse will become less strong over time. Strengthening and weakening of synapses is therefore relevant to debiasing because many debiasing strategies aim at getting participants to unlearn certain biases and to form new associations. In long-term potentiation, an increase in intracellular calcium leads to a recruitment of AMPA receptors to the postsynaptic cell membrane, and therefore increased sensitivity to glutamate. Long-term depression occurs through a decrease in membrane AMPA receptors over time. This causes the postsynaptic cell to become less sensitive to glutamate. We now have the neurological basis for a type of synaptic plasticity that can allow a person to unlearn a certain bias over time. Long-term potentiation and long-term depression are particularly important processes during REM sleep. This is because REM sleep serves to maintain and strengthen memories until they are transferred outside of the hippocampus, where they are erased from the short-term memory factory, and then allowing the synapses in the hippocampus to be used to encode new associative memories. We will see exactly how LTP and LTD are involved during REM sleep in the next couple of slides. Sleep, in fact, plays a big role in allowing for LTP and LTD to take place. This is because of the way that cells in the hippocampus fire during REM sleep. Hippocampal place cells work to make a map of an animal's environment and are most active during peaks of theta wave frequency. Theta waves are waves that happen during REM sleep. When hippocampal neurons fire in phase with the peaks of theta oscillations, long-term potentiation occurs at synapses. Meanwhile, when hippocampal neurons fire during the troughs of theta oscillations, long-term depression occurs at synapses. To determine if REM sleep is specifically for long-term depression and therefore unlearning, or long-term potentiation and therefore for strengthening of memories, Poe et al. Tested the activity of hippocampal neurons during sleep. Researchers found that neurons that were active in new places while the animal was awake did in fact discharge at peaks of theta waves during REM sleep. This suggests that long-term potentiation is occurring then. Researchers also found that once a location is familiar to an animal, place cells reverse their primary firing phase with respect to local theta oscillations during REM sleep. The time course with which place cells switch from novel peak firing patterns in REM sleep to familiar trough firing patterns corresponds with the time course for memory consolidation from the hippocampus to the neocortex. The research here suggests that REM sleep is critical for both unlearning certain associations and forming new associations. Here, we see that mice struggle more to complete reversal learning tasks following sleep deprivation. This evidence has consequences for cognitive debiasing strategies. An understanding of the neurobiology involved in debiasing suggests that sleep may be critical for unlearning a bias. Sleep deprivation, impairments, or disorders may affect one's ability to unlearn a bias. At the same time, encouraging sleep could be a debiasing strategy. In this experiment, mice that underwent sleep deprivation had a significantly higher number of failures in reversal learning tasks compared to mice that did not undergo sleep deprivation. Across 6 blocks of training, we see that sleep-deprived mice consistently underperform compared to control mice.
While there are many behavioral studies and much neurobiological evidence that provides insight towards reversing biases, there is no agreed-upon general method for debiasing. Biases are inherently different for everybody. Individual and cultural differences will affect the outcomes of different debiasing strategies. The Hines study, for example, showed us that different levels of experience may also determine the effectiveness of a debiasing strategy. It seems that overall, insufficient information has been collected on debiasing to draw a general conclusion for how to most effectively implement it in workspaces and other social institutions. There is no be-all, end-all strategy for debiasing that can be used in every situation. However, current research does tell us that there are certain things we can remind ourselves of to minimize the effects of implicit biases and help prevent them. Our biases and heuristics rely on past experiences and pre-processed information that may be insufficient to accurately assess certain situations. Being skeptical and gathering more information about something can strengthen our decision-making when faced with a related scenario. Many of our biases are a result of intuitive affective reactions. Being aware of these emotional influences can help us make more reasonable decisions. Using analytical type 2 processes like metacognition and mindfulness can help us override type 1 intuitive judgments. The Hines study we examined earlier was a good example of using confidence estimation as a self-assessment technique to improve performance on exams. Neurobiological evidence suggests that our sleep is important for forgetting and forming new associations reflecting our day-to-day experiences. Getting a healthy amount of sleep may be a necessary step to overcoming biases in general. Overall, there's evidently a lot more to consider to really understand effective debiasing, but hopefully this presentation helped you understand some current practices used to overcome biases and made you think about steps you can take to be more aware of your biases in everyday situations.